Good afternoon now, I suppose, for you. We're here for a Behind the Walls tour. My name is Mike Frey with Noyes Development. We're at our Highlands at North Bethany subdivision, and we're very excited to bring you a virtual Behind the Walls and hoping we can get back to doing these in person again soon. I'd like to start out by thanking our sponsors for today. We have Energy Trust of Oregon and PGE sponsoring this and making it all possible. Thank you to them. They're always a great partner to us. So today we're going to kind of go through and do our best to present virtually what we would usually do in person together, and then we're looking forward to doing some Q&A afterwards through our Zoom call. As we get into this, I just want to give a brief history of who Noyes Development is and what we've kind of been doing here. So Noyes Development is a local home builder. We build about 50 homes a year in the Portland metro area, and we've been doing this since 1993. We're known as a high-performance home builder, and we build homes that are above code. As code changes, that brings a lot of these things into the picture, so we're going to talk about that a lot today. Even though this isn't a code-specific class, it will be relevant. At Noyes, we're very focused on the community and making sure that we're doing the right thing for our homeowners and for the community around us. And it's just been an outstanding company to be a part of. I'm very pleased to get to help run it. So some of the things that make us special at Noyes are our zero energy ready standard for nearly every home we build. For people who might not be familiar with zero energy ready, what that means is we have a home that's built and we've modeled it and we've run all this information to make sure that when the home is finished and all the systems are done and it's occupied, that if somebody puts solar on the roof, the solar system installed on the roof will be able to offset all of the energy use over the course of the year. Now there are going to be times where in the winter we're not producing as much energy, and through net metering we're going to send that back to PGE, the utility, and we're essentially putting that in the bank. So we're banking this excess energy, or we're in the winter we're drawing from our bank. In the summer when we're producing more, we're putting that into the bank so we can draw it back on the winter. It ends up over the course of the year being zero. So that's a great benefit to our homeowners, and it's a great benefit to the community and our world. So once that solar is installed, that becomes possible. And we have it set up so that that's all ready to go. We have careful roof planning that comes into place here. So right now we're looking at the west face of the home. And between the east face, the west face, and the south face, that's where we need to make sure we pick up all of our solar potential. So we make sure we leave room and we keep it clear for that. As we're looking up at this house, we also see our Tyvek home wrap up there. And that's where a sheetrock window is located, so it's temporarily uninstallable. They've been loading sheetrock. But looking around that area, you can see another important detail for our homes. We have a rain screen wall system to make sure that we drain any moisture out that finds its way behind the cladding. Now, cladding is just another word for siding, and what people often don't realize about siding is that it only keeps out about 90% of the bulk water that hits the house. So in our climate, that says that maybe 3 or 4 inches is going to get past the siding and find its way to the materials behind that. And that's not a very exciting proposition. So what we have is this rain screen system where you can see some vertical battens, and most of it's covered right now because the house is nearly completely sided. But you can see some vertical battens, and you can see what the black strip underneath the gable, you can see that that's a vent. And basically this allows for drainage and drying. The air can flow behind that, and water can drain out and dry out. And that takes it to a very safe system, and it manages all the bulk water issues. We also use fiber cement siding, which is very durable and high quality roofing material. As part of our solar ready work, we're going to transition our way into the garage here, and we're going to show some of how that works on a very simple level inside the home. So inside the garage, we have our main electrical panel, and we also have a conduit that runs from the garage up into the attic. And this creates a pathway so that a solar contractor can run a wire up from here to the attic, and then ultimately it can stub it through the roof when it's finished. We have a lot of space for them to make their connections. And in addition to that, we also leave some space in the panel to make sure that there's room for future solar. So this part of Solar Ready is very simple. There's really not that much to it. It's really a conduit, a junction box, some space in the panel, and from there, the hardest part is planning the roof and making sure that we leave room for everything and we don't have, vents and things in the way. But Solar Ready is definitely something that is easy to do, and it's code mandated now. An important thing to remember is you can slightly change what the code requirement is and follow the ETO Solar Ready option, and it's just a little bit different, still meets code, but you can actually get paid incentives by Energy Trust of Oregon to do the work the code's telling you to do right now, so you should take advantage of that while you can. We also have all of our homes set up with one EV outlet. So this is a NEMA 1450 outlet where somebody can plug in their electric car and charge it. And most of our homes, in addition to being zero energy ready, actually with the full size solar system installed, could probably charge your car for an entire year worth of driving, which is a pretty nice benefit. Some additional systems in our garage include an exhaust fan, and we talk about indoor air quality. A lot of times we're thinking about inside the house. Inside the garage is an important step to protecting inside the house. As much as we seal off our house and try and keep the garage and the house very, very well separated, every time somebody opens the door to go in and out, they're going to be potentially allowing things to pass, and nothing's perfectly sealed. So this fan is connected to a motion sensor, and every time somebody comes in or out of the garage, it's going to automatically turn this on with a timer. And that's going to keep some of those pollutants in the exhaust out of the home, protect that indoor air quality. It's a very simple thing to do. It doesn't cost very much, but it's a tremendous benefit to the homeowner. We also have a pre-plumb for a central vac system, and we use Gary's Vacuum Flow and their Hydro-Hose system in all of our homes. The pre-plumb is standard, and we offer the option to finish it out for our customers. And so basically what this system does is a traditional vac, you're going to carry a hose around. As traditional central vac, you're going to carry a hose around. This one, the hoses actually go inside the wall, and you're able to pull those hoses out and vacuum and go throughout the house whenever you need to. It's very convenient. I like to tell people when my kids were little, I taught them how to clean up after themselves using the central vac system. You pull the hose right out of the wall, clean up the mess under the table, put it back, and it was a lot easier than getting them to get a broom and take care of all that. So benefits of this, not only is it easy for your kids to clean up their messes, but also a traditional vacuum that you go around, handheld vacuum, doesn't last very long, and in addition to the replacement cycles that you have on those, they actually kick most of that dust and stuff back out into the air. So this system actually exhausts, when the system's installed, it actually exhausts out through this pipe and sends any of those particles and stuff outside of the house, in addition to the filter that it has in capturing most of the bulk stuff in its canister. So it's a really great system for indoor air quality as well. We have, in our homes, we use natural gas tankless water heater, and this is a 0.97 EF system when installed. Right now it's not here because we're not quite to that stage. But this is a condensing system, so it means it's very, very efficient. It vents directly outside of the house here, and it doesn't take up very much space, and it only produces the hot water on demand, so it's not constantly storing the water. There are also great heat pump water heaters available, another option within the market for a good system. We're going to be talking about ductwork a lot. One of the new code things is ducts inside is essentially a requirement. And what we see and don't see above us here in the garage is a whole lot of ductwork that's running and serving the house. So what we do in all our homes is all of our homes have ducts inside, and what we can't see above us is the traditional floor system. We have, we use floor trusses, open web floor trusses for all of our floor framing, and the ductwork is running through there. Now, in order to make that inside, we take a piece of OSB and we install it on the bottom side of those floor trusses, And we create then an insulation space underneath that to make sure that those ducts are truly inside the conditioned space. So we have 12 inches of insulation above us here, dense packed insulation, making sure those ducts are inside. So logistically, I think builders are probably going to say, so what do I do with inspections? Our inspectors come through and they do a mechanical inspection before we put the OSB up there. They see that, and then they come in and they get to do their final framing inspection after that OSB has already been installed. So it's not really a big sequencing issue. As we transition back into the house, we're going to see a lot more of ducts inside, but that is a really important factor for how you can accomplish that in a traditional two-story home with living space above the garage. We have a lot of air sealing details in the garage that work their way into the home to make sure that we have a nice, healthy, tightly sealed home as well. So in addition to that garage exhaust fan, that central vac, we do a lot of things to make sure that everything's sealed off well and that we've separated those spaces. As we kind of walk our way back into the house here, you're seeing this dense pack insulation. We've got R23 blown-in blanket insulation in our walls. This has become pretty common these days. It provides a much better insulation value than a typical batt, and it provides a warmer, more comfortable, quieter home. And if you think about batt insulation, when we're trying to install around electrical boxes and plumbing and things like that, usually it's not installed very well. You end up with gaps and compressions in areas that just don't really seal up properly, get insulated properly. This blown-in blanket is able to fill the cavity completely. It goes around wires, around pipes, things like that, and it gets a true insulation value into the home. It's a really great system, and it's so easy and accessible these days that it's absolutely something that anybody can have in their home. For our windows, we use Milgard windows, and they have a special fourth surface coating on them. And what that means is there's essentially a reflective coating on the inside of the glass, which is not the norm. And what that does is if I hold my hand against this window right now, I can literally feel the heat from my hand radiating back off the glass into my hand. So this is a standard vinyl double pane window, has some additional gas and seals and things to improve the quality. But then with that fourth surface, it takes us to a 0.24 U value weighted average in the house, which is really efficient. It's going to save money, but when you think about a cold window, most of the time, in the winter, you're going to feel like that's stealing the heat from your body, and instead it's actually sending it back to my body. So it's going to make the home much more comfortable. So all these things are great. We want to make sure the house lasts a long time though. One other piece that we have here is you can see down at the bottom of the window, we have a sill pan installation. And what that does is it ensures through this sloped sill, this is sloped slightly to the outside, and this is all back caulked, that if there's any water that does try and find its way behind any of the flashing and then any of the siding, and it gets to this window location, that this is going to keep it from coming into the house, and it's going to direct it outside the house, and it's going to allow it all to drain out. So that sill pan and the rain screen are some incredible durability strategies that we're using in this home. We also feature advanced framing. We're going to kind of talk about that a few times as we work our way through the home. And advanced framing can maybe sound a little intimidating, but it's really pretty straightforward. So what we do is we have 24-inch on-center wall framing in most places. You'll see some places where the spacing doesn't allow for that. But we stack most of our floor system directly on top of a stud. As we can see as we walk over here, we have this floor truss that drops down right onto a stud at 24 inches on center. The same thing's going to happen upstairs with our trusses. And people a lot of times will ask, so isn't 24-inch on center framing, isn't that weaker? Isn't 16-inch on center better? Isn't more better? And you've got this nice stacked linear load compared to having them offset. Now we keep a double top plate still, which makes it easier for the framers to work and keeps some things a little bit more conventionally installed. But by installing these at 24 inches on center, especially with today's lumber prices, we save money, we save material, and we get more insulation in. I think most people would rather have warm insulation in their wall instead of a stud, which acts as what we call a thermal bridge, and it allows the heat and cold to transfer inside and outside. So less framing is actually better in this case. And we also have insulation above our window here, where we have a rigid polyiso insulation where the space between the structural header and the drywall is, and that creates a much warmer condition at those header locations wherever the structure allows. So we'll see a little more advanced framing upstairs. We can see some ductwork in the ceiling above us here, and this is the ducts inside that we're talking about, and it's really important with the new code cycle that's coming out. So essentially, code's going to require ducts to be inside the conditioned space. There's going to be a provision for deeply buried ducts in the attic, but that won't be as efficient, it won't be as healthy in the end for the home or for the occupants. So the ducts inside is truly the better of those two options. And if you're building a 2-story home, you're probably going to have some of the ducts inside anyway, because not everything can go in the attic and be deeply buried under insulation. So at that point, you may as well put all of the ductwork inside. It's really not going to be much more difficult. It's not going to cost any more. It should actually save you money to keep them inside through less material in the ductwork. So as we look at all of this, we use an open web floor system. And that just means our truss company makes these floor trusses for us, and it makes it really easy to run all this ductwork through. It also makes it easy for the electricians to run all their wires through, the plumbers to run all their pipes through, and it's a pretty clean system. Still requires some planning. You still have to make sure you have a way to get between the two spaces, but it's really pretty simple. We've also done this. Another option for people is to use traditional I-joist. And people a lot of times go, how can I get this ductwork through an I-joist? By changing to a 14-inch deep I-joist, you have plenty of room to get all the ductwork through. It does require planning. You have to work with the floor designer to make sure that you pick the right locations for all the main ducts to go. You have to make sure that your trades understand that they have to have certain spacing between the holes. So a plumber can't come in and run a big waste line too close to one of these big duct runs, or it will compromise the floor. It's all very possible to do. We did it that way for a number of years, and I know other builders still do that. So that's an option for people. This open web floor truss is another option, and it's one that has worked well for us. So as people are kind of looking at that, I think that's going to be some useful information to consider. You do have those options. You can price out the costs and what's going to work best for your homes. We're going to work our way upstairs in the home here, and as we go, we'll talk a little bit more about some of the framing that we use. We use what we call optimized framing. And now Builders First Source is our lumber company, and they're much more than just a lumber company. They're a trade partner to us, and they have this system called optimized framing that a number of lumber yards are using right now. And essentially what that means is we have our lumber that's all pre-planned, and they go through and they take our plans and they run them through AutoCAD or another design system. And if we look right here, you can see these little X's on the plates. And what these are showing us is the stud layout for the home. And they kind of have a packet. And it's almost like building a Lego set where you follow all of the details for that, and you work your way through the packet, through the binder for the home, and the framers can know exactly how the layout goes. And now the benefits of that, you can see some more of it above this door here where it's showing where the cripples are going to get installed. The benefit of this is that normally a lot of these pieces are cut on site, and there's a tremendous amount of material waste. So by having this all pre-planned, they cut these things together, they label them, they bundle them, and they ship them out to the job site. The material waste is reduced dramatically on the job site. So it saves money in wasted material that you would have otherwise, and it reduces waste. We actually worked with Clean Up Mark and figured out how much wood waste was coming off the jobs, and it was quite a big difference. So this is a system that is accessible as well, a nice complement to advanced framing. So we're going to talk about mechanical now a little bit. Another big thing for code, I'm walking into our mechanical closet for all our ductwork being inside. With the ducts inside code, you'll probably have something similar to this, where you have a closet that you carve out somewhere in the home, or you build a conditioned closet in the garage for the air handler that you use. And with the new code, there's still a lot of question about this, but some kind of ventilation strategy is going to be required beyond just an exhaust fan. So what we have here is we have a fresh air system. This is a duct that brings fresh air in from outside. This is a little damper that's electronically controlled, and this is going to get wired into a controller that's not present yet. But what happens is we bring this fresh air in, we send it in, and we tie it into the return air system. That return air is then mixed with the outdoor air. It's sent through a filter here, and then it runs through the air handler, and it runs through our ductwork to the house. So we're distributing this fresh air all the way through the home after it's been filtered. And by mixing it in here, we're taking the indoor air temperature and the outdoor air temperature, and we're tempering that a little bit so we're not getting just a blast of the outdoor air. And it's filtered, so allergens are taken care of for that. It's a really good system. And then in addition to that, the air handler, anytime it calls for heat or cooling, is going to default to pulling this air in. And then we use a calculation based on ASHRAE 62.2 for how much fresh air is needed for the home for the occupants. And if it doesn't meet it just when it's on its runtime already, it turns this on, turns on the air handler, and it sends the fresh air to the house. Now, the code requires balanced ventilation now. So what we're doing, and we've been doing this for years, is we connect this fresh air to a laundry fan out here. And now those are interlocked, so anytime the fresh air turns on, this exhaust fan turns on. So we're sending fresh air into the house, and we're exhausting stale air from the house at the same time to avoid any pressurization or depressurization, and they're on a roughly balanced level. This particular fan has 3 settings. You can set it to a lower speed or a lower CFM, middle CFM, or higher CFM, depending on how much airflow you need. So it provides some flexibility. Now, there's a chance that the code may not follow this method. It's still being determined. They may require a different system, but there's a good chance this is going to be the new code required ventilation system. It's a great system. It works well, it gets the fresh air to all the different parts of the home, it filters it, it balances things pretty well, and I'm hoping that this is where code goes, but that's still to be determined. So we've talked about our central vac system. We can see inside one of the vac ports here just as we're walking past it, point that out. And then talked a little bit about advanced framing. Another part of advanced framing is just within our trusses. So beyond just our wall framing, the amount of lumber that we use there and the spacing there, we have raised hill trusses in our homes. And we can see here above the plate, we have from here up to the bottom of the roof sheeting, we have 11¼ inches. And typically, you would just have your truss sitting down directly on top of the wall and very little space there. That means by the time you get out to the edge, there's essentially no insulation. You get cold spots and comfort concerns from that. By having this 11¼ inch raised heel, we're able to get about an R28 value all the way out to the wall, and then much more as you get further in. And we got to use an R49 insulation for the rest of the home. We also use some air sealing methods. You can see this foam sill seal right along the top plate here. And people a lot of times think about that going along the edge of, along the concrete below the green plate on the home. And what that foam sill seal does in this case is it creates a gasket. So as we press our drywall up against this, it essentially just seals up as it's attached. And anywhere there's unconditioned space above, attic space above, that strip is just installed, and it tightens up the house a great deal as the air exchange requirements ultimately start changing with code, or people try and build a tighter home. This is a very simple strategy, very low cost, and very accessible to people that can really help tighten up the home. I think the benefit people a lot of times don't realize is through the stack effect, pressure comes from the bottom of the home and it works its way up through the home and out through the attic. And so while it feels like maybe this isn't such a critical spot to seal, a lot of our air loss through that stack effect is forced through the attic. So sealing this up is really important. We've got a number of other air sealing details that we use that people are pretty familiar with in terms of using foam around some of the edges of things, or caulking plates, and those are great strategies. We've been able to build homes that are, when we perform blower door tests for all of our homes, that most of our homes have been averaging about 1.6 ACH 50, I believe, which was really, really tight. It's a very well sealed home. And we've been working our way down on that air tightness and getting tighter and tighter. We've also been partnering with AeroBarrier, Northwest AeroBarrier, on air sealing. So in addition to what we've done in this home already, they're going to come into the home during sheetrock, and they're going to run their equipment, and they essentially pressurize the house, and they push their sealant out into all the different parts of the house. It's a great presentation to watch from them if you ever get an opportunity. But through partnering with them, we're in a spot now where our homes are averaging 1 ACH 50 through the blower door testing. They're very tight, and we've worked out a system that's more efficient for our insulator and for Northwest AeroBarrier, and provides a very consistent outcome for us. So that's a pretty exciting new technology that's going to make a big difference for builders who struggle with getting their homes tight. I think we've talked about a lot of things. I want to make sure that I talk a little bit about our heating system beyond the ductwork. We use an electric heat pump, and we've used gas forced air furnaces in the past, but we switched to heat pumps when we started realizing our homes were basically zero energy ready, and we started going, we can power this from the roof and have clean power, clean energy taking care of the heat for our homes. So we switched to high performance, high efficiency variable speed heat pumps. And these are very efficient. They don't take up very much space. They operate in a very quiet manner. And the systems we're using, we have two different sizes that we have to use in our homes, but the one of them is 11.7 HSPF and the other is 13.6. And that's all very kind of technical jargon, but it just means they're very efficient. You know, a typical code heat pump is going to run about 8.5, I believe, these days, HSPF. So these are much more efficient than that. They cool the home much more efficiently. So we have cooling standard, and it's more efficient cooling, and we have this great heat source. So that's a strategy we've used, and I think that's a future thinking strategy that's going to be important as people talk about electrification of homes. I'm sure there's going to be something that we forgot today, or that I forgot today, and we'll have some time in our Q&A to go through that. I do want to again thank our sponsors, ETO, Energy Trust of Oregon, and PGE. I want to thank all of you for joining us, and thanks to the HBA for putting this together, and look forward to the Q&A time together.